Today we are going to start our lesson number 3, polynomial. Okay, polynomials. In this polynomial, in the term, the poly means the Greek word poly means it is many, and normal means terms. Okay, the algebraic expression which having the many terms. Okay, is known as many means more than one or more than one. It is a polynomials. Okay, now we see the exact definition of the polynomial. We discuss about. Let us discuss. Let us study. Introduction. Okay, in this first we take the topic cover in that polynomial. Let us study introduction to polynomial, operation on polynomials, degree of the polynomials, synthetic division, value of the polynomial. All this topic, remainder theorem, all this topic cover in this lesson. Okay, let us discuss. Let's discuss. Okay, p cube minus 1 by 2 bracket square plus p m square plus 2 m cube minus under square root of 3 m raised to 5 6 are all algebraic expression. Okay, here cube p cube minus 1 by 2 p square plus p m square plus 2 n cube minus under square root of 3 m raised to 5 6 are all algebraic expressions. Okay, in all algebraic expression given above, the powers of the variables are positive, integers or 0, that is whole number. In this, suppose in this we consider the expression p cube minus 1 by 2 p square plus p. Here the p cube having the index is or the power is 3, p square having 2, p having 1. These all are the positive integer, that is whole number. In an algebraic expression, if the powers of the variable are whole numbers, then that algebraic expression is known as polynomials. Okay, what do you mean by the polynomial? Polynomial generally it having the one or more terms, but exact mathematical definition of a polynomial is in an algebraic expression. Algebraic expression means it having the numbers and variables together with the 4 basic operations, like that. Okay, now here the actually definition about the mathematical definition of the polynomial is in an algebraic expression in the powers of the variables are whole numbers, then that algebraic expression is known as polynomials. Okay, for example, 6 is also a polynomial. Why 6 is a polynomial? Because if we consider the 6, if we take the here the 6 x raised to 0, x raised to 0 is equal to 1, 6 into 1 6, means 6 is a polynomial, and here the power of the variable is 0, 0 is a whole number, that is why 6 minus 7 1 by 2 0 square root of 2 etc are constant numbers, can be called as constant polynomial. 0 also a constant polynomial. Let us discuss it. Square root of square root of y plus 2 and 1 by y plus 1 are polynomials. Are polynomials? No. Why? Let us see. Both are not polynomials. Why? Because in square root of 2 plus 2, square root of y plus 2 is equal to the square root of y. How to represent it? Y raised to 1 by 2 plus 2, hence power of y is 1 by 2, which is not a whole number, which is not a whole number. That's why the square root of y plus 2 is not a polynomial, is not a polynomial. Next, the y 1 by y plus 1 is equal to the y raised to 1 by minus 1 plus 2. Here power of y is negative 1, which is not a whole number. That's why y 1 by y plus 1 is not a polynomial. Okay, understood? types of a polynomial. Okay. The previous classes we see some types of polynomial. Types of a polynomial based on number of terms, means norms, terms. Okay. The first is 2x 5. In this 2x comma 5, 2x having the one term, only one term in the polynomial is known as a monomial. The second examples, x square plus x m raised m cube minus 3m, it having each expression having two terms, each polynomial having two terms. Two terms in the polynomial is known as a binomial. Sorry, it is binomial, by mistake it is polynomial, monomial. Sorry, it is, you consider it is binomial. This typing mistake. X square plus x plus 1 m cube minus 3m minus 2. It having how many terms? They are, sorry, again here the typing mistake. It is three terms. You consider three terms in the polynomial is known as a trinomial. Okay, you consider this chart. In this some typing instead of monomial, in second case it is binomial, and instead of two terms in the instead of two terms it is instead of two terms is in the polynomial it is three terms. These are the types of a polynomials based on numbers, monomial, here it is binomial and trinomial. Okay. Now we see the next. Polynomial are written as p of x, q of m, r of y according to the variable base. For example, p of x is equal to x square plus x plus 1, or q of m is equal to the m cube minus 3m minus 2, 3m minus 2. Okay. Now we see degree of a polynomial in one variable. What is mean by the degree? What is mean by the degree of a polynomial? Okay. Now we see in the polynomial 2x raised to 7 minus 5x plus 9, which is the highest power of the variable here. Answer is highest power of the variable, highest power is 7. In case of the polynomial in one variable, the highest power of the variable is called the degree of the polynomial. What is meant by the degree? In case of the polynomial in one variable, the highest power of the variable in the degree of the polynomial. Okay, means here in this example 2x raised to 7 minus 5x plus 9, here which is highest power? 7 is the highest power. That is why the degree of this polynomial is 7. Just like 10, degree of any non-zero or the constant polynomial is 0. Degree of 0 polynomial is not defined. Types of a polynomial. Now we see the types of a, again we see the types of a polynomial, but here types of a polynomial based on degree, like that. There are again three types. First one is, suppose we consider 3x minus 1 7. Here the degree of each polynomial is 1. That is why linear polynomial, and the general form of a linear polynomial is standard form of a polynomial is x plus b. Here a, b are coefficients and a is not equal to 0. Here the standard form is x plus b. Here why a is not equal to 0? Because if you take the a is equal to 0, it is not a linear. Why? Because here the degree of polynomial in this case is 0 and it is not linear. That is why it is. If we here we consider degree of polynomial, here we should not take a is equal to 0. Now the second type examples are x square plus x plus 1 m square, and second one is m square. Here the degree of polynomial is 2. That is why the linear it is a quadratic polynomial. It is quadratic polynomial. If the degree of a polynomial is 2, then it is known as a quadratic. Okay. A standard form of a quadratic polynomial is ax square plus bx plus c. Here a, b, c are coefficients and a is not equal to 0. Again why a is not equal to 0? Because again if you take the a is equal to 0, then it is not a quadratic. It is not a quadratic. Now let us see the next. X cube plus x square plus 1 and m cube minus 3m plus minus 2. Here here the both polynomial having the degree is 3. That is why it is known as a cubic polynomial. What is the definition of the cubic polynomial is? If the polynomial having degree is 3, then that polynomial is known as cubic polynomial, and the standard form is ax cube plus bx square plus cx plus d. Here a, b, c, d are coefficients and a is not equal to 0. A is not equal to 0. A is not. Why? Again if you take the a is equal to 0, then what will become? 0 into x cube is 0. What we get here? What is remaining here? Bx square, and bx square here the highest power is 2. That is why it is not a cubic, it is quadratic. Okay. Now we see the next. It is the general form a n x raised to n plus a n minus 1 x raised to n minus 1 plus a n minus 2 x raised to n minus 2 plus so on plus a 2 x square a 1 x square plus a 0 is the polynomial in x with degree n, a n minus 1, a n suffix n minus 2, a 2, a 1, a 0 are the coefficients and a n is not equal to 0. This is a general form. Now we see the standard coefficients and the index form of a polynomial. For example, we consider the polynomial Pm is equal to the 3m raised to 5 minus 7m 5m cube plus 2. Now we see the example. First is the standard form. First we write down in the standard form, means write the polynomial in standard form. How the standard form? Means we rearrange this polynomial 3m raised to 5 minus 7m plus 5m cube plus 2 in descending or ascending orders of power. Here the which is highest 3m cube. Here 3m raised to 5 we write down here first 3m raised to 5. After that which is highest 5m cube minus 7m plus 2. Okay. After that, in case what is meant by the index form? In the index form, write in the index form by considering all the missing terms in with coefficient 0. Suppose in this polynomial 3m raised to 5 plus 5m cube minus 7m plus 2. Here which are terms are missing? After 5 what we require? 4. After 3 what we require? 2. Means here the m raised to 4 and m square terms are missing. In case of the missing terms, what we do here? We add missing terms by taking coefficient is 0, like that. yeah, m raised to 5u plus m raised to 4 is missing here, we take here plus 0 m raised to 4 plus 5 m cube, similarly plus 0 m square minus 7 m plus 2. If you add this missing term, the value of this polynomial is not doesn't is why, because 0 is to 0 into m square again 0. Okay. Now the next form is coefficient form. In the coefficient form, write the coefficient in bracket like this. We just collect the coefficients in bracket. 3 0 5 0 minus 7 2. 3 is the coefficient of m raised to 5, 0 is the coefficient of m raised to 4, 5 is the coefficient of m cube of 0 is the coefficient of m square, minus 7 is the coefficient of m, and 2 is a constant, and the degree of polynomial here 5 highest term. Here the coefficient form, in this how in the coefficient form how many numbers is 6, means it is degree plus 1. Here degree is 5 plus 1, it is 6. There are 6 numbers. Okay. These are the standard coefficient index form. In the standard form, we rearrange the equation according to the ascending or descending powers of the variables. In index form, we add a missing term by taking coefficient is 0. In coefficient form, we just in bracket we write down the coefficients. Okay. And lastly the degree. Okay. Let us see some examples. Write the coefficient of m cube in each term of the polynomial. M cube minus 1, the coefficient of m cube is okay. Here in this m cube, here the m cube minus m minus 1, here the coefficient is m cube does not having any coefficient, means it is 1. In case of here second, 3 minus 3 by 2 plus m minus under square root of m cube, here the coefficient of this m cube is minus under square root of 3. The second example is write the following polynomial in standard form. Minus 7y plus 5y square y raised to 5u plus 3y cube minus 1 by 2 plus 2y raised to 4 minus y square, means here to writing the polynomial in standard form, we rearrange the polynomial in descending or ascending powers of the variable. Here the which is highest, here the y raised to 5, then the standard form is y raised to 5, after that the 2y raised to 4 plus 3y cube minus y square minus 7y minus 1 by 2 is the standard form. Means to writing the standard form, we rearrange the terms of a polynomial in descending powers of the variable. Mostly we use the descending. Okay. The third example, write the following polynomial in the coefficient form. The example polynomials are is 2m raised to 4 minus 3m square plus 7. Here first to write in the coefficient form, what we do, first we standard form, index form. Here the which is already the polynomial given in standard form, just we write down the index form. In this index form, what we see here, the which term are missing, cube and m term also missing. We add this term to m raised to 4 plus 0 into m cube minus 3 m square plus 0 m plus 7, and just we write down the coefficients 2 0 minus 3 0 7. This is the coefficients form. How many numbers here? 2 1 2 3 4 5. Here the 4 and the degree of 5 and degree of polynomial is 4, means it is 4 plus 1. Okay. Now the fourth example, write the polynomial in index form. Okay. 5 0 0 0 minus 1. Here how many numbers here? There are 5 numbers. Okay. Now the degree of this polynomial is 5 minus 1 is the 4, means we write down here. Index form is 5x raised to 0 plus 0x cube plus 0x square plus 0x minus 1 is the index form of a given polynomial. Okay. By using this information, try to solve practice set number 3.1. Thank you.